Yeah, hi everyone, Mr. Markwick here. Today I'm going to show you how to factorize expressions, and I'm going to start by showing you how to remove common factors. So this is a type of factorizing that's probably the most common. It's the first thing you should look for when you're asked to factorize an expression. Given there might be an expression with two terms, look for a common factor between those two terms. If there's an expression with three terms, look for a common factor between all three of those terms, and so on. Anyway, last video I did with you guys, we looked at expanding expressions. So we're looking at expressions like this that contain a bracket, and we'll use the distributive law to expand that expression or remove those brackets and created an expression that contained no brackets. Okay. Now, factorizing is the opposite of that. Basically, what we're going to do is we're going to start with an expanded expression, an expression that doesn't contain any brackets, and we're going to put it back in the form where it does contain brackets. So we're going to take an expanded expression and put it back into the form as a factorized expression. Basically, expanding and factorizing are opposite operations, just like multiplying and dividing are opposite operations. Okay, so that's why it was really important that we did expanding before we can do factorizing. Now, let's get straight into two examples. I've got two simple examples here today, but you can use this or these concepts that you're basically picking up from these two examples for some more difficult questions. Now, here I have an expanded expression, and I want to factorize it. So it doesn't contain any brackets. I want to put it back into an expression that contains brackets. Now, if you look at the example that I had on the left-hand side already, sorry guys, I'm just going to rub that out there for a second, because you can look at basically we're at this point and we want to go to this point. Okay, so we've got an expression with two terms. What we want to do is basically put a term in front, and then there'll still be two terms inside the bracket. So that's what we want to get to. Before we can do that, what we need to do is look for a common factor between the two terms that make up our original expression. Okay, now both of those terms, minus 3x and minus 12, can be divided by 3. Okay, so 3 is a common factor. And I'm going to say, for the ease of this, I'm going to say the highest common factor is minus 3. Because they're both negative terms, they can both be divided by a minus number. In this case, minus 3. They're both 3 and 12 are both in your 3 times tables. And because they're both negative terms, we're going to make that a minus 3 as our highest common factor. Now, it's that minus 3 that comes out the front of the brackets. And then I set up my brackets. Now, it's the opposite of factorizing. So, basically, we need to look at minus 3 times by what number will give us minus 3x. Okay, it's the opposite of what we were doing the other day. So, minus 3 times what equals minus 3x? Well, it's minus 3 times x. So, the first term inside my bracket is x. And that's how you can check to see if you've done it right. Minus 3 times x equals minus 3x. Okay, so we've got the right term inside the bracket and the right term at the front. Now, the second term in the original expression is minus 12. So, minus 3 times by what equals minus 12? Minus 3 times 4. So it needs to be a minus times a positive to give us a negative answer. So it's minus 3 times positive 4. So the answer, the second term inside the bracket here is positive 4. Okay, so like I said, the way of double checking to make sure you've done it right is you can re-expand that. So if I did minus 3 times x equals minus 3x, minus 3 times positive 4 is minus 12. Okay, all right. So that was nice and easy, and you can see there that the highest common factor was actually the coefficient of x in the first term of the expression. In the second example, that's not the case. So we have to find, so I'm going to write this one down, we have to find a term that, a number that both of these terms can be divided by. And we want to find the highest term, because if I look at these numbers here, 20 and 30, they're both in our 2 times tables. Yep, that's great. They're both in our 5 times tables. Yep, fantastic. But the highest common factor between 20 and 30 is actually 10. So I want to say the highest common factor here is 10. But to fully factorize it, I actually want to find the highest common factor for the whole term. So the whole term is actually 20a squared and positive 30a. So a is actually considered part of our highest common factor. So in fact, 10a is the highest common factor. And what we do with that 10a is we put that 10a at the front of our brackets. The highest common factor goes at the front of your brackets, and you set up your bracket, and 10a times by what number gives me 20a squared? Well, 10 times 2 is 20, a times a is a squared, so 2a, so 10a times by 2a is 20a squared. Alright, the second part of my bracket here, the second term inside my bracket is going to be what? 10a times by what? Gives me 30a. It's as simple as 30a divided by 10a is 3. Okay, so this part of the bracket is 3. And because I've got a positive number here and a positive number here, it's, okay, still a positive number in between. That's really important, that sign in front of our brackets as well. All right, so that's a bit of a crash course on how to factorize by removing common factors. Look, they get more challenging than that, but I guess for my class, guys, we're going to start easy and build up to some of the more challenging questions. So hopefully that helps, and good luck.